Hello everyone, this is Steve. Thanks for joining me. With hyperbolas, there's so much going on that we don't really have time to talk about all the theory involved, so we're just going to focus on getting that sketch drawn and then telling people some information about the sketch. So let's get started. This hyperbola right here is going to open up and down because we have the y squared as the positive term and the x squared term is behind the minus sign. So we are going to draw a hyperbola that opens up and down. To draw a hyperbola, we need to draw our reference rectangle here. So what I'm going to do is I'm going to take the square roots of the number under y squared and x squared. So the square root of 49 is 7, square root of 36 is 6. And to draw my rectangle, I'm going to go up and down 7 and left and right 6. So 1, 2, 3, 4, 5, 6, 7. And then down 7, 1, 2, 3, 4, 5, 6, 7. And then left and right 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, then I'm drawing my rectangle here with dashed lines to help me draw my hyperbola. And now, going through the corners of the rectangle and through the center, which is the origin, I'm going to draw my asymptotes. So there's one asymptote. And there's the other asymptote. Now, because this particular hyperbola opens up and down, these are vertices right here and here. So my vertices are going to be 0 plus or minus 7. That is also, those 2 points are also the endpoints of what I call my transverse axis. So my transverse axis connects the vertices, and it's going to be 14 units long. My conjugate axis is the other way across the box. My conjugate axis, and it's only going to be 12 units long. In this case, the transverse axis is longer, but that's not always the case. All right, so to sketch in my hyperbola itself, I need to go through the vertex here, and I can't enter the box or touch the asymptotes. So it's kind of like that, and like that. Okay, so the red part you see up there, where the part that's not dashed, is the actual hyperbola itself. All the dashed blue lines just help us draw it. Okay, what else can we say about this thing? Well, we can give its domain and range. So its domain is actually negative infinity to infinity. There's no breaks as you go from left to right. But the range is broken up into 2 intervals, negative infinity, oops, got excited there, negative infinity all the way up to negative 7. Let's try this again. Negative infinity all the way up to negative 7, including negative 7, and then 7 to infinity. All right, what else do we have? We have the asymptotes. Now the asymptotes are going to be equations for lines. And the secret to writing the equation for the line on these is knowing the y-intercept is right here at 0. And you can find the slope of one of your asymptotes by counting up here and over here. So that's up 7 over 6. So therefore the slope of the asymptote is 7 over 6. So the asymptotes are going to be y equals 7 to 6x. But the other asymptote, that's just one of them, is going to have the exact same slope, negative. So it's going to be plus or minus 7 over 6. So those are your 2 asymptotes right there. Finally, the last thing we might want to tell someone about the hyperbola is where the foci are. Now the foci are always in the same direction as the vertices, the same direction the hyperbola opens, but they are beyond the box. So the secret to finding the foci is to add the numbers under x squared and y squared together. So to find our foci, we will do 49 plus 36, which is going to be 85. Then we have to square root that number. So square root of 85. And that's how far we go up and down to get to our foci. Now, 85 is actually just a little bit bigger than 9. So our foci are going to be right here and right here. Sorry, I'm sliding the drawing around so much, everyone. There you go. And then the ordered pair, since they're up and down, would be 0 plus or minus square root of 85. Okay, everyone. I think that's everything. Thanks for watching. Hope that helped.